What we're looking at here is an example where we want to multiply two rational expressions together. And this is actually a quite simple one because the first step that is indicated here at the side, factoring the numerator and denominator if possible, doesn't apply. As you can see, our rational expressions are just monomials in the numerators as well as in the denominators. So the second step is to state any restrictions by looking at the denominators. So if I look closely here, I'll notice that, well, I can't have a 0 for x in my first denominator because that will give me a product of 0, and I also cannot have y equal to 0 for the exact same reasons. And the same restrictions carry on in the second fraction as well. So that takes care of all our restrictions for now, and we can start to simplify. So step number 3 says cancel any common factors in the numerator and denominator. Well, let's take a look. Common factors in numerator and denominator. So the 6 and the 5 in the first one, well, those can't simplify each other, but this x goes into x squared, and we're left with x to the exponent 1. That's all over 5y. Times, well, 8 and 15 do not divide each other, so I'm going to write 15 up here, but x and x cancels out. And the y to the 3 and the y to the 4, well, that becomes y to the exponent negative 1. And that's all over 8. So we've done step number 3. Next, we're going to multiply numerators and denominators together and see what we get. So multiplying across, I'm going to look at these two terms multiplied together. So 6 times 15, that will give me 90. Then I have x times y to the negative 1, all over 5 times 8 is 40. And then I have a y here. Now I can simplify this even further because 90 and 40 are both divisible by 10. And also over here, I have the y and the y to the negative 1. That'll become y to the negative 2 because up here there's an exponent of 1. If I subtract that from the negative 1 above, I get negative 2. So now I have 9 x y to the exponent negative 2, and that is all over 4. And that's it. There is your final expression.